Welcome to this explainer. Today we're diving straight into the mind of DeepMind's CEO Demis Hassabis and looking at how his team's artificial intelligence is fundamentally solving some of the ultimate mysteries of our universe. From his early days as a childhood chess prodigy, all the way to recently snagging a Nobel Prize, Hassabis has consistently viewed AI not just as some cool tech product, but as the ultimate tool for genuine scientific discovery.
But before we get into the really heavy stuff, like biology, human DNA, and the future of human survival, we actually have to start with a shocking moment of machine creativity that changed absolutely everything we thought we knew about computers. Seriously, what actually happens when a machine starts inventing entirely new knowledge on its own?
So here is our roadmap for today. We'll be covering 1. Creativity in the machine. 2. Solving biology's grand challenge. 3. Decoding human DNA. 4. The commercial AI race. 5. Guardrails and AI safety. And finally, 6. Unlocking the universe. Let's get into it.
Section 1. Creativity in the machine. The game of Go.
You know, in the ancient game of Go, players rely heavily on human intuition and beauty, not just raw mathematical calculation. Because there are literally more possible board positions than there are atoms in the universe. You simply can't just crunch the numbers. When you ask a Go master why they played a certain way, they don't give you a math equation, right? They usually just say, it felt right. It's almost an artistic pursuit.
Think back to decades ago when IBM's Deep Blue beat the world chess champion using sheer brute force. That was what we call an expert system. Programmers literally fed it all the rules and human heuristics, and it just dumbly executed them using massive computing power. Deep Blue couldn't even play a simpler game like tic-tac-toe. DeepMind's AlphaGo, on the other hand, was a learning system. It learned from experience using deep reinforcement learning. So it wasn't just executing human knowledge, it was actually building its own. Big difference.
And exactly how it built that knowledge became stunningly clear on March 10, 2016. In Game 2 of AlphaGo's match against world champion Lee Sedol, AlphaGo played Move 37. It was placed on the 5th line of the board early in the game. Honestly, it was a move any human Go teacher would slap your wrist for making. It was totally unexpected. But it ended up being the exact critical piece needed to win the game hundreds of moves later. Move 37 wasn't just a winning play. It was a real spark of genuine non-human creativity, where a machine actively invented new knowledge.
DeepMind then took this even further with AlphaZero. They completely stripped away all the human data, starting as a total blank slate with zero knowledge, just the rules of the game. It played 100,000 games against itself, completely randomly at first. Then it took the slightly better moves, trained a new version, and repeated the process. In roughly 17 generations, going from a complete blank slate in the morning, it was beating world champion chess and Go systems by dinner time. It had successfully generalized the ability to learn. Absolutely wild.
Section 2. Solving biology's grand challenge. The protein folding problem.
200 million. That number is just staggering. That's the number of proteins DeepMind mapped. Proteins are the building blocks of life, and their exact 3D structure dictates exactly what they do. Figuring out just one structure used to take scientists years of agonizing work and hundreds of thousands of dollars. When DeepMind cracked this with AlphaFold, they originally thought, hey, let's set up a server where scientists can email in requests. But Hassabis does some quick math in a meeting and realizes their AI is so fast they could just pre-solve all 200 million proteins known to science in about a year. So they just did it. And the kicker? They gave the whole thing away for free.
But getting the structure is really just step 1, right? Once you have the shape, you need to find a chemical compound that binds to that exact protein without accidentally attaching to the 20,000 other proteins in your body, which is what causes nasty toxic side effects. AI allows scientists to run massive in silico virtual screenings, testing thousands of compounds in minutes. But, and this is absolutely crucial, this pipeline always ends with rigorous physical testing in a wet lab. The AI's predictions have to actually work in the real world.
Take the nuclear pore complex, for example. It's one of the biggest proteins in the human body, essentially this giant gateway that lets nutrients in and out of a cell's nucleus. Because it's so massive and intricate, its shape was a total mystery for years. But just months after AlphaFold was released, boom! Researchers used it alongside experimental data to finally map this beautiful, vital structure.
Section 3. Decoding human DNA. Editing life's code.
So, for decades, scientists have been intensely focused on just the 2% of our DNA that actually codes for proteins. But that leaves a massive 98% of non-coding genetic code, which was largely a complete mystery. Understanding this vast unknown space is the exact kind of massive data puzzle that AI is perfectly built to solve.
And this is exactly where AI teams up with other Nobel Prize-winning breakthroughs. CRISPR is this amazing tool that can edit genes, but for a lot of complex diseases, scientists don't actually know which specific mutation is causing the problem in the first place. AlphaGenome basically acts as the map. It analyzes those massive genetic sequences to predict exactly which single-letter change is harmful. AlphaGenome points the way, and CRISPR goes in to make the fix. It's an incredible partnership.
Section 4. The Commercial AI Race. A ferocious competition.
Now, there's a really deep internal tension at play here behind the scenes. In Hassabis' ideal world, balancing AI innovation with safety would look like a giant, slow, CERN-style international science experiment. Very methodical, cautious, step by step. But the reality is that breakthroughs in language models, like transformers, which Google actually invented, were much easier to scale than anyone anticipated. When OpenAI dropped ChatGPT, it just triggered this ferocious, hyper-competitive commercial and geopolitical race overnight.
But despite all the intense pressure of this race, releasing AI to millions of users actually brings some major benefits. Yes, progress is moving at lightning speed right now. And yes, it democratizes the tech, giving everyday people access to tools that are just months behind the most advanced labs in the world. But crucially, you can't truly understand how robust a system is until it's stress-tested by millions of smart people actively trying to break it in the real world. That intense, massive feedback loop is what actually makes the technology safer over time.
Section 5. Guardrails and AI Safety. Controlling Intelligence.
While people love to obsess over those long-term sci-fi doomsday scenarios, the real medium-term risks are way more grounded. First, there's the genuine danger of bad actors taking AI that was built to design medicines and repurposing it to design toxins. And second, there's the rise of agentic AI. These are systems that can autonomously complete entire complex tasks without any human intervention. Making sure those independent agents have ironclad guardrails so they don't accidentally or intentionally circumvent their goals, that is an incredibly hard technical challenge. So, to manage the more immediate risks, like misinformation and deepfakes, DeepMind developed SynthID. It basically acts as a permanent invisible digital watermark embedded directly into AI-generated images, video, and audio. It allows systems to instantly flag fake content to users. It's a really pragmatic, right-now solution to label AI content while we figure out those bigger, medium-term guardrails we just talked about.
Section 6. Unlocking the Universe. Solving root nodes.
Alan Turing famously described theoretical machines that could compute anything computable. Well, Hassabis and many neuroscientists actually believe that our own human brain is essentially an approximate Turing machine operating on classical computation. And if that's true, there might be absolutely no mathematical limit to what an AI system can eventually compute, mimic, or understand about the world around us.
Think of human knowledge like a massive tree. Solving a foundational root node unlocks entire branches of new science above it. AlphaFold was really just the first root node. If an artificial general intelligence system can help us crack nuclear fusion or room temperature superconductors, we suddenly have infinite clean energy. Rocket fuel becomes essentially free to produce. We could actually begin traveling the stars and mining asteroids. Solving just one root node unlocks a completely new era of human flourishing.
I want to leave you with this really provocative thought. For a long time, we've defined human specialness by our creativity, our intuition, our unique ability to solve problems. But as machines master science, as they play incredibly creative moves like Move 37, and as they map the very building blocks of our own DNA, we are rapidly approaching a moment where we are going to truly find out what makes us wonderfully, uniquely human. Because if a machine can do all the computing, what exactly is left for us? Thank you so much for joining this explainer, and keep questioning the universe around you.